I mean, it's honestly ridiculous. All right. All right, so let's do this again. So in this video, I'm going to cover 3.3D transformation, compressions notes, okay? And we're going to answer the essential question, how do I apply vertical compressions to a given function, okay? So remember, again, you're going to be looking at your functions in their vertex forms for your quadratics and your absolute values. Again, a review. H is going to be your horizontal shift. So if you have a positive H, you're moving to the left. Negative H, you're moving to the right. So they're opposite because your H, you have to flip the sign. If your K, if you're dealing with your K in vertex form, it shifts up or down. Positive shifts up, negative shifts down. If A is negative, we learned it's reflected. And we also learned if A is greater than 1, you have what's called a vertical stretch, which means your function will get closer to the y-axis. Okay, so when you have a stretch, it gets closer to the y-axis. So what happens when you have a compression? When it compresses. So A will be greater than 0 but less than 1. A will be greater than 0 but less than 1. So you're going to be dealing with some fractions. Okay? So when this happens, you have a compression. When your function compresses, it actually gets closer to the x-axis. Okay, so let's look at some examples. So here in this first example, A, you can see here we have a compression because our A is less than 1, greater than 0. Here we have a horizontal shift and a vertical shift. So we would say we have a vertical compression by 3/5. We're going to shift left by 6. And we're going to shift down by 3. Okay. All right. How about in this next one? And remember, y is the same as f of x. Okay. Well, we have, first of all, we have a negative. So that's going to mean a reflection. Then we have a number smaller than 1. So we're going to have a compression. We are going to have a horizontal shift and a vertical shift. So start with the reflection. So it is reflected over the x-axis. Okay. We have a vertical compression by a factor 2/3. We are going to shift right by 5, and we're going to shift up by 2. A lot of changes in that one. All right. So how would we do it the reverse? How would we take our parent function and add all these reflections? Well, first of all, it's going to be vertically compressed by a factor of 1/4. So that means our A is going to be 1/4. Our H, it's translated 90 to the right, so we're going to have a negative 9 for our h, and it goes up by 4. So our k will be plus 4. So use your vertex form. So I'm going to have 1/4 times x minus 9 plus 4. Remember your vertex form, which is f of x equals a times x minus h plus k. Okay? All right, so here, it's going to be reflected over the x-axis. So I know my a is going to be negative. It's vertically compressed by a factor of 1/3. My h is going to be 0 because I don't have any movement left or right. And then my k is going to be a negative 2. So let's fill them in. F of x equals negative 1/3 times x squared, I don't have an h, minus 2. All right, wonderful. Again, vertical compression is when a is greater than 0, less than 1. Vertical stretching changes the y values. The graph is vertically compressed or shrunk by multiplying, okay? So in other words, when it gets vertically compressed or shrunk, it actually moves closer to that x-axis. All right, so let's look what the parent function is. So I'm going to start with 0 here because my h is 0 and my k is 0 with this parent function. So then I'm going to figure out negative 1, negative 2, 1, and 2. All right, great. So I have 1, I have 2. Absolute value of negative 1 is 1. Absolute value of negative 2 is 2. Okay. Well, what is my h and k in this one? Well, again, they are 0. I'm going to start with 0 and 0. I'm going to do my negative 1, my negative 2, my 1 and 2. And this time, this is my function rule. So what happens when I put 1 in here? Well, this is going to be 7, 5. Same with here. What happens when I put 2 in here? Well, it's going to be 6 over 4 or 3 over 2, which is equal to 1.5. Okay. All right. So let's see what this looks like. So again, it's going to be a compression. I can tell right here. So my h is 0, my k is 0. So let's fill in these numbers. 1/4 times negative, no, let's start with 1. So 1 and negative 1 should be the same. Okay, well, what's 1 squared? 1 times 1 is 1, times 1/4. I'm going to end up with what? 0.25. And I'm going to end up with it here. All right, so what happens when I put 2 in here? Well, what's 2 squared? 4. What's 4 times 1/4? Well, 4 1/4 is going to give me 1. Or you could do it this way. It turns into a 4. I'm going to multiply the top numbers and the bottom numbers, and I get 4 over 4, which is equal to 1. Okay? So, if this graph right here that's already there is my parent function, is x squared, what does this vertical compression look like? Well, the 0, 0 is going to stay the same. So at 1, instead of being at 1, I'm going to be at 0.25. So way down here, okay? Let me spread this out a little bit. Oops. Go to erase, erase. So I'm actually going to be way down here, okay? Then at negative 2 and 2, I'm going to be at 1. So here I'm going to be at 1, and here I'm going to be at 1. So this is what my function looks like. And remember, it's a u because it's a quadratic. So as you can see, the compression made it move closer to the x-axis. Kind of compressed it down. And this was a vertical compression. By 1/4. Okay. Let's do one more, and then I'm going to leave the last two for you to work on. And make sure you come to me if you're struggling. I'm actually not going to do 2. I think I'll do 4. And then I'm going to leave 2 and 3 for you. All right, great. So here, I can see that I have a reflection. I can also see that I'm going to have a compression. Okay? And I'm also going to have a shift. So, but because we have a compression, we have to set up our table of values. And when we do that, it's going to be graphed in the right place. You don't have to try to shift it manually. Once you calculate your table of values, you'll be in exactly the right place. It'll do the shifts, all the movement for you. Okay? So my H here is going to be 2 and my K is going to be 0. So I'm going to have 2, 0. I'm going to figure out 1 and 0, 3 and 4. Wonderful. So let me do my function rule. So I'm going to put 3 in here. 3 minus 2 is 1 squared. I'm going to end up with negative 0.5. All right. So what happens if I put 1 in here? All right. Negative 1 squared. So I'm still going to end up with 0.5. It's going to be the same. What's going to happen at 0 and 4? Let's find out. So 0 minus 2 is going to be negative 2 squared is 4. So I'm going to have negative 1/2 times 4. I'm going to end up with 4 over 2 negative, and I'm going to end up here with negative 2. Will the same thing happen when I do 4? Let's find out. 2 squared, 4. Yep, same thing. So negative 2. Once I do that, I need to graph it. So my vertex is now at 2, 0. As you can tell, we moved 2 to the right because of this H right here. Okay, see how it automatically did that? Okay, so at 1 and at 3, I'm going to be about halfway. So here and here, okay? And then at 4 and 0, I'm going to be, oh, sorry, negative 0.5. Sorry. So I'm going to be here and here. And then at 0 and 4, I'm going to be at negative 2. So I'm going to be 0 and 4. I'm going to be at negative 2. Okay? Then I can draw my beautiful U, making sure it looks like a U and not a V. And all of my transformations happened using my table of values. So my transformation were reflected over the x-axis, vertical compression, by 1/2, and shift two units. Okay, there we go. So you try these last two, and if you have any issues, please come and see me.